In this video, we're going to talk about how to take derivatives involving trig. So you do have to know your basic derivatives. You have to have these basic ones memorized. So the derivative of sine x is cosine, and the derivative of cosine x is negative sine. The derivative of tangent is secant squared x, and the derivative of cotangent is negative cosecant squared x. The derivative of secant x is secant x tangent x, and the derivative of cosecant is negative cosecant cotangent. Now, you got to be careful not to get them confused to know which ones are negative. So an easy way is if you know these three, these are very similar. Derivative of sine is cosine, cosine is negative sine. But what's going to happen is anytime you take the derivative of one of your trig functions that starts with c, cosine, cotangent, or cosecant, the answer is going to have a negative. So that's an easy way to memorize that. Now, what if we have more than x in here? So here's an example, the derivative of sine of f of x, and I'm using f of x to represent something that's more than x. Maybe it's 3x squared, maybe it's 2x to the fifth, but there's more going on than just a x. In this example, you would have the derivative of the sine is cosine. The inside is always going to stay the same, okay? But then I have to multiply it by the derivative of the inside. Okay, so that's what that would look like. You're never going to change the inside of your trig function. So whatever's in here is going to be in here, but then you're going to have to take the derivative of it. The reason you don't see that here is because when I take the derivative of x, I get 1. So I'm really multiplying this by 1. Memorize these trig functions and know them well. And then an easy way to memorize this, and I like to memorize it in words because it's easier for me in my head to say a few phrases and memorize something than to think of the notation, but it's up to you. Derivatives of trig functions, inside stays the same, times the derivative of the inside. So that's exactly what I just did here. I took the derivative of the trig function, that's cosine, derivative of sine is cosine. The inside stays the same, that's f of x is f of x, and then times the derivative of the inside. So that would be f prime of x. Let's look at a few examples. Here we're asked to find the derivative, and in this one, notice there's no parentheses like you see here. They don't technically have to put parentheses. A lot of times you'll see them, but because there's no plus or minus here, it's understood that everything after cosine is part of it, so is inside the parentheses. So I can add them there. This one, which has the 3x squared minus 5, it has to be in parentheses so that we understand that the minus 5 is also inside the trig function. So just be careful with that. Okay, the derivative of y is dy dx. Now, we're going to take the derivative of the trig function. So the derivative of cosine is negative sine. The inside is always going to be exactly the same, and then we're going to multiply by the derivative of the inside. And the derivative of 2x cubed is going to be 6x squared. Now, I will probably rewrite this. I'll take this negative 1 there, times the 6x squared, and make that negative 6x squared. And then I will write my sine of 2x cubed. I just like to simplify it, clean it up a little bit. So that's how you'll see me write it. Okay, over here, the derivative of y is dy dx. The derivative of tangent is secant squared. Inside will always, always, always be the same, times the derivative of the inside. So the derivative of 3x squared is 6x. And the derivative of negative 5 is 0. So we actually just have the 6x. So I can write that in front. 6x secant squared of 3x squared minus 5. That's my derivative. Okay, here we have a number out front. That doesn't really matter. That just gets multiplied by your derivative of this trig function here. So I'm going to have negative 3 times the derivative of this. So the derivative of sine is cosine. Inside will always be the same, times the derivative of the inside, which is going to give me 20x to the fourth. And then I would probably multiply this by the negative 3. So negative 3 times 20 is negative 60x to the fourth. Taking this and multiplying it by the negative 3, and then I'm going to write cosine of 4x to the fifth. Okay, last example, we're going to have the derivative here. Now, the derivative, the 2 is going to stay here, but the derivative of secant is secant x tangent x, whereas this kind of represents the x, so that's going to be the same in both trig functions. So the derivative of secant is secant, this is all going to be the same, tangent. Now, I didn't leave myself really enough room for this, but so this is just the derivative of secant, secant tangent, and then times the derivative of the inside. And since there's two terms there and it's going to come out to a derivative of two terms, I do need to put it in parentheses. So kind of imagine that off to the side here. Times the derivative of 3x to the fourth is going to be 12x cubed. And the derivative of negative 2x is going to be negative 2. So I have this has to be multiplied by all of this. Now, you could leave it like this, but I kind of like to write this in front. So what you'll often see me do is I'll leave this 2 out front here, and then I'll have the 12x cubed minus 2, and then I will write all of this. So then it'll be secant of 3x to the fourth minus 2x, and my writing is getting smaller because I don't have enough room, but you get the idea. And that is how you take derivatives with trig functions. So you definitely have to have all 6 of those memorized. Okay? I will see you in the next video.